Why is our entire galaxy being pulled towards an invisible monster? You are sitting perfectly still. At least, that is what your senses are telling you. But your senses are lying. Right now, as you sit there, the planet Earth is spinning on its axis at over 1,600 kilometers per hour. That same Earth is orbiting the Sun at an astonishing 107,000 kilometers per hour. That is fast. But it is nothing. Our entire solar system, the Sun and all its planets, is hurtling through the Milky Way galaxy at a mind-bending 828,000 kilometers per hour. We are completing one full orbit of the galactic center only once every 230 million years. Even that is not the speed that should concern you. All of those movements are orbits. They are predictable. They are stable. But there is another motion. A strange motion. A motion that is not an orbit. Our entire galaxy, the Milky Way, a colossal structure containing 400 billion stars, is being pulled. Right now, our entire galaxy, along with our neighboring Andromeda galaxy and dozens of smaller satellite galaxies, is being dragged across the intergalactic void. We are moving at an almost unbelievable velocity, 2,160,000 kilometers per hour. That is 600 kilometers. Every single second. This is not an orbit. This is a one-way trip. We are being pulled towards something absolutely massive. Something invisible. A region of space that astronomers call the Great Attractor. It is a gravitational anomaly so powerful that it is overriding the expansion of the universe itself. But there is a terrifying problem. When astronomers point their most powerful telescopes in the direction we are headed, they can see almost nothing. The monster that is pulling us is hiding. And it is hiding in the one place in the sky we can almost never look. What is this cosmic giant? Why is it invisible? And what happens to our galaxy when we finally get there? The answers will fundamentally change your understanding of your place in the cosmos. Because we do not live in a quiet, expanding universe. We live in a universe that is full of invisible rivers, currents, and monsters, and we are trapped in one of them. Before we dive deeper into this mystery, I have a question for you. When you look up at the night sky, do you feel a sense of peace or a sense of motion? What does the universe feel like to you? Drop your thoughts in the comments below. I read every single one, and the most interesting answers might get featured in the next video. And if you're the kind of person who loves cosmic mysteries like this, hit that red subscribe button. Because what I'm about to reveal next will change how you see the universe. Now, let's go back to the beginning. Our story begins not with a discovery, but with a profound confusion. For most of the 20th century, our understanding of the cosmos was defined by one single, elegant idea: expansion. In the 1920s, Edwin Hubble observed that distant galaxies were all moving away from us. The farther a galaxy was, the faster it was receding. This was the elegant proof that the entire fabric of spacetime was stretching. The universe, born from a Big Bang, was expanding like a balloon. This concept, the Hubble flow, became the bedrock of cosmology. It implied that, on the in-betweens of gravity-bound clusters, everything should be moving away from everything else. But in the 1970s, astronomers started to find problems. They were looking at the cosmic microwave background radiation. The CMB. This is the afterglow of the Big Bang itself. It is a faint, cold echo of creation that fills the entire universe, uniformly, in every direction. This CMB radiation is the ultimate reference point. It is the rest frame of the universe itself. If you are perfectly still in the cosmos, the CMB should look perfectly uniform. But when astronomers measured it, they found a shocking anomaly. The light from one side of the sky looked slightly hotter, and the light from the other side looked slightly colder. This is a Doppler effect. It meant one thing, and one thing only. We were moving. We were not still relative to the rest of the universe. Our entire local group of galaxies was plowing through the cosmos at 600 kilometers per second relative to the CMB. This was not the Hubble expansion. This was something else. This was a peculiar velocity. A peculiar velocity is a motion in addition to the Hubble expansion. Imagine you are on a moving walkway at an airport. The walkway itself is the Hubble expansion, carrying everyone along. But a peculiar velocity is like you deciding to run along that walkway. The universe was expanding, but we were also running. This raised an immediate, terrifying question. Why? What could possibly be so massive, so unbelievably dense, that it could grab our entire local group of galaxies, a region of space spanning 10 million light-years and containing a mass of over 1 trillion suns, and pull it through space like a feather on a string? This was the birth of the mystery of the Great Attractor. In the 1980s, a team of astronomers who became known as the Seven Samurai set out to map the universe in a new way. They did not just look at where galaxies were. They painstakingly measured their peculiar velocities. They wanted to see if other galaxies were running, too. What they found was a cosmic conspiracy. They measured thousands of galaxies in our cosmic neighborhood. And they discovered that not only were we moving, but a vast collection of galaxies, spanning hundreds of millions of light-years, were all moving. And they were all moving in roughly the same direction. It was not a random scatter. It was a flow. A cosmic river. And our galaxy, the Milky Way, is not just a passenger in this river. We are just one tiny speck of driftwood caught in an immense current, all flowing toward a single, unseen destination. By mapping the direction and speed of this flow, the Seven Samurai astronomers were able to triangulate the source. The source was a region of space located about 150 million light-years away, in the direction of the Centaurus and Norma constellations. Based on the velocities they were seeing, the astronomers calculated what must be there. The object, or collection of objects, had to have a mass of 10,000 trillion suns. That is 10 to the power of 16. It is a number so large it is almost meaningless. It is the mass of a massive supercluster of galaxies. There was only one problem. When they looked in that direction, there was nothing. Or rather, there was something, our own galaxy. The Great Attractor, the cosmic monster pulling us across the universe, is located in the worst possible place for us to see it. It is located directly behind the disk of the Milky Way galaxy. By the way, something amazing is happening in the comments section. Last week, a user named Cosmic Wanderer asked an incredible question: if the universe is expanding, how can anything pull us? That is the perfect question. And the answer is that gravity is a local bully. On the largest scales, expansion wins. But in a local neighborhood, if a bully is big enough, gravity always wins. The Great Attractor is our local bully. What do you think? Let me know below. The best comments get pinned, and I might even make a video answering your question. Now, here's where things get really strange. This patch of sky, the one that hides the Great Attractor, has a name. Astronomers call it the zone of avoidance. It is not called this because it is dangerous. It is called this because, for optical astronomers, it is a place they avoid. Why? Because our own galaxy is a brilliant, messy, crowded place. The central disk of the Milky Way, the galactic plane, is filled with everything. Billions of stars. Trillions of tons of gas. Unimaginably vast clouds of interstellar dust. When we try to look through this disk with a normal, visible light telescope, it is like trying to look at a street lamp on the other side of a dense forest, during a blizzard, while someone is shining a spotlight in your face. The light from distant objects is absorbed. It is scattered. It is blocked. This cosmic fog, our own home, creates a blind spot that wraps around the entire sky. And by a terrible coincidence of cosmic alignment, the very thing that is pulling us sits directly behind this impenetrable veil. We are hurtling at over 2 million kilometers per hour toward a destination. And our own home is blocking the view. For decades, the Great Attractor was a ghost. We could feel its pull. We could measure its influence on our path. We could even point to the exact spot in the sky where it should be. But we could not see it. This created a schism in astronomy. Was it real? Was it a mistake in the calculations? Or was something even more bizarre happening? Could the pull be coming from something we are not supposed to see? Something like dark matter? An ocean of invisible matter so vast that it bends spacetime without emitting a single photon of light? The mystery only deepened. We were speeding toward an unknown object, hidden in a zone of avoidance. The only way to find the monster was to abandon light. The only way to see it was to look for the invisible. We were speeding toward an invisible monster, hidden behind a veil of our own making. To find it, we had to abandon the light we have always trusted. We had to learn to see the invisible. How do you pierce an impenetrable wall of gas and dust? You use light that does not care about walls. Visible light, the kind our eyes see, is fragile. It is a tiny, delicate wavelength. It scatters easily when it hits a particle of dust. The Milky Way's zone of avoidance is a fog bank for visible light. But other wavelengths are bullies. Radio waves, with their long, powerful oscillations, can sail through the dust clouds as if they are not even there. And X-rays, with their incredibly high energy, can punch straight through the gas. So, in the 1980s and 90s, astronomers did exactly that. They pointed their new, powerful radio telescopes, like the one at Parkes in Australia, directly into the zone of avoidance. It was like turning on a new set of eyes. The fog vanished. And on the other side was the monster. It was not a single object. It was a flood. A tidal wave of galaxies. Where our visible light telescopes saw only a handful of dim, obscured stars in our own backyard, the radio telescopes revealed everything. Dozens. Then hundreds. Then thousands of entire galaxies, all clustered together in the exact direction of the Great Attractor. They had found its heart. Scientists gave it a name, the Norma Cluster. This was not just any cluster of galaxies. This was one of the most massive, densest clusters known in our local universe. It is a galactic metropolis, a colossal city of galaxies, many of them ancient, giant elliptical galaxies, each one far larger than our own Milky Way. They are all packed together, churning and colliding, superheating the gas between them to millions of degrees. This superheated gas is what gave them away. When astronomers pointed their X-ray satellites, like the German Rosat, at the same patch of sky, they saw an enormous, glowing blob of X-ray light. It was the scream of a cluster so massive, its gravity was crushing the gas between its galaxies until it burned, invisibly, at 50 million degrees. This was it. This was the Great Attractor. The Seven Samurai were right. The object they had predicted, the object that was pulling us, was real. The mystery, it seemed, was solved. We were being pulled by the immense, combined gravity of the Norma Cluster and all the associated filaments and walls of galaxies that surrounded it. But, this is cosmic bow. And you know, it is never that simple. When the astronomers finished their calculations, their excitement turned to confusion. They added up the mass of all the galaxies they could see in the Norma Cluster. They calculated the mass of the superheated gas from the X-ray glow. They added everything together. And the number was wrong. It was not big enough. The mass of the Norma Cluster, as observed, was enormous. Perhaps 1,000 trillion solar masses. But it was not enough. It could only account for a fraction of the pull, a fraction of that 600 km per second speed that is dragging our local group. The monster was real, but it was not strong enough on its own. So what was going on? We had found the culprit, but the crime did not match. If this information blew your mind, hit that like button. It tells YouTube's algorithm to show this video to more curious minds like yours. Together, we're building a community of people who aren't afraid to ask the big questions. And trust me, what I'm about to tell you next is even more mind-blowing. The math problem of the Great Attractor led to two new, cascading questions. First, if the visible matter was not enough, was the rest of the pull coming from dark matter? This seemed like the obvious answer. We know that dark matter, the invisible scaffolding of the cosmos, makes up about 85% of all matter. So, perhaps the Norma Cluster was just the tiny, glowing 5% tip of a truly colossal iceberg of dark matter. The Great Attractor, then, was not a city of galaxies. It was a continent of invisible something. This was a terrifying, yet plausible idea. But there was a second possibility. A more elegant, and in my opinion, a more beautiful solution. What if the Great Attractor is not a thing? What if it is a place? This idea completely reframed the problem. We were thinking of the Great Attractor as a giant vacuum cleaner, actively sucking us in. But what if we are not being sucked? What if we are flowing? This brings us to the year 2014. A team of astronomers led by Brent Tully and Helene Courtois published a new map of the universe. But it was not a map of things. It was a map of motion. They mapped the peculiar velocities of over 8,000 galaxies, creating a three-dimensional map of our cosmic neighborhood. What they were doing was mapping the cosmic watershed. Think of it this way: on Earth, you can define a continent not by its political borders, but by its watershed. Every drop of rain that falls in North America, for example, will eventually flow into either the Atlantic, the Pacific, or the Arctic Ocean. The lines that divide these flows are the watershed boundaries. Tully and Courtois applied this exact same logic to the universe. Galaxies are the raindrops. Gravity creates the valleys and mountains. Their map showed, for the first time, our true cosmic address. They discovered that the Milky Way is part of a vast, previously unknown supercluster. A structure containing 100,000 galaxies, stretching over 520 million light-years. They gave this structure a beautiful name, Laniakea. It is a Hawaiian name. It means immeasurable heaven. And the Great Attractor? It is not a monster. It is simply the bottom of the valley. It is the gravitational center of our entire supercluster. The Great Attractor is the cosmic drain for our entire 100,000 galaxy neighborhood. Our Milky Way galaxy, we are not being pulled by a monster. We are simply flowing downhill. We are a single drop of water in a small creek we call the local group, which is flowing into a larger river called the Virgo cluster, which is in turn flowing into the Great Basin, the Laniakea supercluster. The Great Attractor is our home. This is a profound, beautiful solution to the mystery. It redefines our place in the universe. It gives us an address. It gives us a context for our motion. It is elegant. It is complete. And it is wrong. Or rather, it is incomplete. Because when Brent Tully and his team mapped out the beautiful, flowing structure of Laniakea, they discovered something that sent a new chill down the spine of cosmology. They could see the flow lines of all 100,000 galaxies, all converging toward the Great Attractor. But when they looked at the entire structure, the whole Laniakea supercluster itself, it had a peculiar velocity. Our entire immeasurable heaven is moving. Our entire continent of 100,000 galaxies, the basin, the drain, all of it, is also being pulled. The Great Attractor itself, the very thing we thought was the center of it all, is just another piece of driftwood, caught in an even bigger current. Far over the horizon, beyond Laniakea, lies another, even more massive concentration of matter. An anomaly so large, it makes the Great Attractor look small. It is called the Shapley supercluster. We thought we had found the monster. But we had only found our monster. And it turns out, our monster is running from something else. So what is this new object? How big is the Shapley supercluster? And if our entire supercluster is destined to collide with it, what is the ultimate fate of the Milky Way? We have just pulled back the curtain, only to find a much, much larger stage. We thought we had found the center of our universe. Our home. Laniakea. We thought the Great Attractor was the Great Basin, the final destination for our cosmic flow. We were wrong. Our entire immeasurable heaven, our home supercluster of 100,000 galaxies, is itself moving. The Great Attractor, the very thing we are flowing towards, is being pulled by something else. That something is the Shapley supercluster. And if the Great Attractor is a monster, Shapley is a titan. It is located roughly 650 million light-years away. It is a colossal concentration of matter, the largest, most massive gravitationally bound structure in our observable neighborhood of the universe. We are not talking about 1,000 trillion solar masses. We are talking about 10 quadrillion solar masses. That is a 1, followed by 16 zeros. It is a collection of over 8,000 galaxies, packed so tightly that it is in the process of collapsing in on itself. It is a cosmic megacity that makes our own Laniakea supercluster look like a quiet suburb. And our entire suburb is being pulled towards it. This is the new picture of our cosmos. It is not a simple, expanding balloon. It is a dynamic, complex web. A cosmic tug-of-war. On one side, you have the expansion of the universe, the Hubble flow, which is pushing everything apart. This is driven by the mysterious force we call dark energy. On the other side, you have gravity. And gravity has created a landscape. In our immediate vicinity, there is a giant, empty region of space behind us. It is called the dipole repeller. It is a cosmic void. And just like a mountain repels water, this void is pushing us away. And in front of us is the Shapley supercluster, the single largest valley in our part of the cosmos. So, here is our motion in its entirety. We are being pushed from behind by the dipole repeller. We are being pulled from the front by the Shapley supercluster. And this entire flow, this entire river, is Laniakea. The Great Attractor is just the deepest, most turbulent part of the river, a local whirlpool that we are caught in. This reframes our entire existence. For centuries, we thought we were the center of everything. Then we were a planet orbiting a star. Then a star in a galaxy. Then, we found we were a galaxy in a local group, flowing, somewhere. Today, we know. We are a speck of dust, on a planet, orbiting a star, in a galaxy, that is flowing down a gravitational valley, which is the center of our supercluster, and that entire supercluster is just one more river, flowing into the even greater ocean of the Shapley supercluster. This discovery is humbling. It means our fate is not our own. We are a part of a much, much larger motion. A motion that began billions of years ago. A motion that brings up the ultimate question. What happens when we get there? What is the ultimate fate of the Milky Way when we, and our entire Laniakea supercluster, finally, arrive at the Shapley supercluster? Will it be a collision? A cosmic merger of 100,000 galaxies with 8,000 more? An event so vast it would light up the universe? This is the great, final destination of our journey. Except, it is not. Because the universe had one more secret. One more, final, cruel twist. What we've covered today is just the beginning of a much bigger story. Next week, I'm releasing a video about that other side of the coin, the dipole repeller. The great nothing that is pushing us from behind. And its existence is just as profound as the Great Attractor's pull. The findings? Absolutely shocking. Make sure you turn on notifications so you don't miss it. Click that bell icon right now. Because the universe still has so many secrets to reveal. The final twist is dark energy. In 1998, astronomers made a discovery that shattered cosmology. They observed distant supernovae and found that the expansion of the universe was not slowing down. It was accelerating. Some unknown force, this dark energy, is embedded in the fabric of space itself. And it is pushing the universe apart, faster and faster every single day. For a long time, we thought this was just a problem for the largest of scales. That in our local, gravitationally bound neighborhood, gravity would still win. We believed that Laniakea was strong enough to hold us. We believed that our flow toward the Great Attractor, and Laniakea's flow toward Shapley, was inevitable. But we were wrong. The newest, most precise calculations show a heartbreaking reality. The pull of the Great Attractor is not strong enough. The gravity of our Laniakea supercluster is not enough to overcome the accelerating expansion of space. Laniakea is being torn apart. The very name, Immeasurable Heaven, is a beautiful, fleeting poem. Because this supercluster is not a permanent structure. It is a collection of galaxies that are currently moving in the same direction, but they will not be together forever. And what about the journey to Shapley? That 650 million light-year gap between us and the Shapley supercluster? It is expanding. It is stretching faster than our 2 million km/h peculiar velocity can cross. This is the ultimate, profound, and melancholy truth. We are being pulled by a monster that we can never reach. We are flowing down a river, but the ocean is moving away from us faster than the river can flow. Our galaxy, the Milky Way, will never collide with the Norma cluster at the heart of the Great Attractor. Our supercluster, Laniakea, will never merge with the Shapley supercluster. The Great Attractor is not our destination. It is a cosmic ghost. A promise of a future that will never happen. So what is our fate? Isolation. In the unimaginably distant future, dark energy will continue to stretch the space between galaxies. The galaxies within our local group, like Andromeda and the Milky Way, will merge. We will form one giant, isolated galaxy. But every other galaxy, every other supercluster, Laniakea, Shapley, all of it, will be pushed away from us by the accelerating expansion. They will recede. Their light will redshift. And one by one, they will vanish. They will be pushed over the cosmic horizon, their light unable to reach us, forever. We are living in the cosmic afternoon. A brief, glorious moment when we can see the other rivers and oceans. We can see the Great Attractor. We can see Shapley. But we are watching them as they fade away. The monster that is pulling us is a ghost. It is a map of where gravity wants us to go. But the real, invisible monster, the one that is truly in charge, is dark energy. The force that is isolating us. So, the next time you look at the night sky, remember that you are moving at 600 km per second. And you are moving toward a destination that you will never, ever reach. So, what's your answer to this question? If our cosmic journey has no final destination, does the journey itself become even more important? Drop your thoughts in the comments. I can't wait to read them. And if you enjoyed this deep dive into the cosmic flow, you'll love my video about the Boötes void. It explores the exact opposite mystery, a place where the universe is impossibly, mysteriously empty. The link is in the description, or you can click the card appearing right now. Until next time, keep looking up.